Hey guys, George at SoundTraxx here, and I really hope all of you guys are staying safe and staying healthy and staying sane and getting a lot of model railroading done during all the craziness that's going on in our world today. So first off, I want to thank you for taking the time to join us for our Tsunami2 clinic. Now today we're going to discuss the Tsunami2, we're going to show you some operation examples, and we're going to really dive deep into what really makes Tsunami2 Model Railroaders Reader's Choice Award winner for Favorite Sound Decoder 2 years in a row. So let's get started. So first off on this clinic, we're going to have an overview of sound selections and how you can pick the sound in your Tsunami2 decoder. We're going to talk about steam and diesel examples. We also do have an electric decoder, but we're not going to cover that during this clinic. So be sure to check out our webinars on our YouTube channel for more detail on all of our SoundTraxx Tsunami2 product decoders, so that way you can have a better understanding of all the features that are built into each one. Now also we're going to talk about the features and how to use the decoder so you can mimic what's going on better in the real world when trains are being run. The purposes, using the brakes and things like that, we're going to show you how to do that with Tsunami2. Now we are going to set a few CVs. We're not going to get too overly technical. For technical information and how to set up these CVs, be sure to check out our user's guide for detailed information on how to set up all of these features and more, and all the other things and sound selections that you can find on our website at SoundTraxx.com under the Reference tab, and click on Manuals, and you'll be able to find the Tsunami2 manuals, including the sound selection references we're going to use during this clinic. Now next up, we are going to cover steam and diesel examples, and then at the very end we're going to show a really different aspect of operations, including consisting. So let's get started. So first off, let's cover some of the features in the steam. Now we've talked over and over again about the steam sound selections and how all of the sounds of our steam are represented into our Tsunami2 steam decoder. Now in this, you have several CVs that will allow you to select which sounds play, so that way your decoder can more closely represent the model that you're installing. So for example, CV number 120 determines which whistle plays. Now in the Tsunami2 decoder, you get 90 different whistles to choose from. Now this is a collection of single chime, 3 chime, 6 chime, 5 chimes, all the different whistles that you can find. Now one thing that's important to note, in steam era, whistles were not as standardized as diesels are today. Now while a railroad may have ordered a particular whistle with a particular run of locomotives, it wasn't always the same whistle throughout the entire fleet. Now the other variable factors, there were a lot of times where engineers would pick their own whistle or have their own whistle, and they would climb up onto the locomotive and they would take that whistle off and install their own whistle. And the idea was that way they could have their own personal whistle, and it would add a little bit of extra personality. So when you're going through and selecting a whistle, don't fixate too much on which whistle is supposed to be prototypical, but go through the list and take a listen to them, and you can hear the whistle sound selections on our website at SoundTraxx.com under the Reference, and click on the sound samples. Now you can listen to all the different whistles and pick one you like, or in some of the cases, like for example the Big Boy 4014, you can pick the actual whistle that was recorded off of that in our TSU Big Steam. Now other things you can pick are the bell in CV122, the exhaust chuff in CV123. You can select the air pump or the air compressor in CV124, the dynamo that's going to play in CV number 125, and then which coupler type you're actually using in CV126. So for example, if you're modeling early 1860s, 1850s railroading with Lincoln pin couplers, there's a sound in there for that coupler chosen in CV126. Now some of the other sound selections you can pick in CV112 determines which type of fuel is being used. So whether you have a coal burner locomotive, an oil burner, as one I don't have listed here in front of me, a coal burner with a stoker or an auger which will feed the coal into the firebox, or even an old wood burner. And all the sounds of loading fuel in function 17 will change depending on which fuel type you've selected. Now in CV112, you can also select the type of reverser that's being used, whether it's a manual Johnson bar like you would see in this smaller locomotive, or a big heavy power reverse like you would see in these bigger locomotives. You can determine which one plays when you change directions. Now you can also select the type of injector that's being used, whether it's a manual lifting type injector or if it's a non-lifting type injector that would sit below the water line. Now there are some minor differences between the two sounds, but you can select that again in CV112. Now the other thing you can do in CV112 is determine the chuff cadence. So for example, these two locomotives are what's called a conventional rod locomotive, which means they have 2 cylinders and you get that 4 chuffs per revolution. As the piston moves back and forth, you get 1, 2, 3, 4 chuffs per revolution. Now in the case of a heavy articulated, and this is the simple type of articulated, where you would actually get 8 chuffs per revolution of the wheel because you have 2 sets of cylinders, one in the front, one in the rear. You can also select a 3-cylinder type locomotive in CV112. So again, you have this choice. Now, when you're selecting an articulated locomotive, you can also determine wheel slip. And this is the sound of these 2 sets of drivers going in and out of sync with each other. So how that runs, you can determine the speed: none, slow, medium, and fast. Now, I know we've talked about this before, but just with these sound selections, the choices in CV112, not counting volume controls or anything else that we're going to talk about during the clinic today, you have over 2.1 billion possible different sound combinations out of the Tsunami2 preloaded. All you have to do is select these CVs and determine which ones of those are best for your model. So next up, one of the things we want to talk about is our dynamic digital exhaust feature. Now, our dynamic digital exhaust allows the decoder to read the load on the motor and adjust the tone and intensity of that exhaust chuff based on what the locomotive is doing. So for example, when you're running a heavier train, you're actually going to have that locomotive working harder, especially when you encounter a grade. Well, you're going to want to have that locomotive sound like it, and that's how the dynamic exhaust works. So when your locomotive is starting to go uphill or pulling a heavier train, you're going to hear that exhaust chuff barking. Now, there is a short calibration process that's outlined in a few of our YouTube videos as well as our user's guide, but let's take a look at a really quick example of what the dynamic exhaust sounds like when you're running your train. Now we've got a little momentum in here. CV3 is set to 25 and CV4 is set to 75, so some moderate but not a lot of momentum. We're going to go ahead and move our locomotive forward at about speed step 2 or 3. And you can kind of hear how it's got a little bit of tone, but once we put a little resistance on the tender, you can hear how that chuff has changed intensity because it's working harder against my hand. As soon as I release, you can hear that chuff back down. Now that's a really cool feature that's really exciting and especially fun when you're running your trains around your layout. Now, one of the biggest questions we get is about chuff cadence and, for example, the chuff rate. How do we set the chuff rate? Now, in years past, our decoders had a chuff cam wire, and this wire was attached to a physical cam that was located on one of the wheels of the locomotive and physically triggered internally to create a chuff. Now, the tricky part was that was difficult to install. And so what happens is you ended up having to take apart the drivers and in some cases separate the drivers. Then you had to recorder them and all of this, and a lot of people didn't end up doing it. So we wanted to go to work and try to find a better way to do it. The reason the physical cam existed is because the chuff rate in the original Tsunami was based on a throttle setting. So when you told your decoder to go to speed step 20, the decoder would create chuffs based on the commanded speed step. So for example, at speed step 20, you might get, we'll say, 1.2 chuffs per second. Now, what happens is when you're running uphill with a heavy train, your locomotive may physically slow down and not quite go as fast. Well, there was no interaction between the motor and the commanded speed step, and so therefore the chuff rate continued at a higher rate even though your locomotive was slowing down. It created a very poor illusion of what we were trying to create. So our engineers went to work and they decided a better way to do this was to do a digital cam based on the rotations of the motor. So now when you set your chuff rate in CV114, the decoder is able to identify rotations of the motor and be able to keep your locomotive chuff in time with the rotations of the motor to make sure that no matter what speed you're going, your chuffs will always be in time regardless of your commanded speed step. Now this is watching the back EMF of the motor, so be sure to set that up, then set your chuff rate and get everything dialed in and you'll be really happy with the results. Now, when it comes to the Tsunami2, our Tsunami2 has two different braking systems built into the decoder. You have the independent brake, which as its name implies are the brakes that are actually located on the locomotive by the wheels that will stop the locomotive independent of a train or by itself when it's switching or doing industrial work, things like that. You also have what's called the automatic, and the automatic brake ties into the train down the rest of the train and distributes that braking effort throughout the entire train, and that's the air hose that you see coupled between all the cars. Now, when the engineer wants to make a brake, the automatic part of this is he reduces the brake pressure in that line, and the brakes then will apply to the car. Part of the reason it's designed this way is, let's say, for example, down the line, one of the hoses breaks, comes uncoupled, or catches on something and tears. That air pressure line, if it's relying on positive air pressure to set the brakes, now there's no control of the brakes, and those cars are basically not going to be helping out in the braking effort. So the automatic brake relies on a reduction of pressure. Now, SoundTraxx Tsunami2 is able to reproduce both. Now, let's talk quickly about how we'll do it, and then we'll show you a quick example of how it works. So F11 is the brake application. So when you press the F11, you're actually applying the brakes. Now, the independent and the automatic both have their own independent braking rate that you can determine with a CV. Now, to determine which brake plays, CV112 is either on or off. Default is off. Your locomotive is in independent brake mode. So when you hit the F11s, you're hearing the independent brake sound. Now, when you press the F12 on your throttle, now your decoder is going to transform and go into automatic train brake mode. And you're also going to hear the compressor start working to charge that train line. Now, this compressor will run for about 30 seconds. In the real world, it takes about 10 to 15 minutes to charge the train, depending on how long the train is. Now, this way you get a better experience of what's actually happening. So once you tie into the train, your F12 is on, you start running. When you press the F11 now, you're actually going to hear the sounds of the automatic or the train brake. You're going to hear the air reduction out of the locomotive. Now, what's really cool is we have a product called SoundCar, and in the SoundCar decoder, you can actually set the brakes. So it works the same way, except, of course, when you're tied into the train, if you hear the air reduction on your cab, you get to hear the squealing coming from the cars, which means that sound is being distributed throughout the train, which is a really cool effect. I encourage you to try it out. Now, first off, let's get everything set. So first off, you want to add a little bit of momentum, because in the real world, trains don't start and stop on a dime. So we want to set CV3 for our acceleration. We're going to set it to a nominal rate of about 75. Now, our deceleration rate in CV4, we're going to set to a value of 150. And this gives you some good response. It takes a little longer to come to a stop than it does to accelerate. And so you get a little bit better of an experience. Now, we're going to set our independent brake rate to a value of 178. And this represents a minus 50 to the deceleration rate in CV4. That way, you essentially have a braking rate now of 25 when you're using the independent brake. Now in CV118, we're going to set the rate for the automatics, and we're going to set that to a value of 75. And what that's going to do is it's going to add 75 to our braking rate, so that way it takes a lot longer to bring our train to a stop. So that way you can see the difference between an independent locomotive and a fully loaded train. So now let's go ahead and take an example. We're going to see how that runs, and we're going to show you how to put that into play. Now, isn't that a really cool effect? It really adds some extra realism to our railroad operations. So let's take a quick look at our function mapping. Now, our function mapping defaults, they can vary between different manufacturers, but for the aftermarket SoundTraxx Tsunami2, you're going to see the function mapping shown here. Now, you're going to see a lot of standard stuff. Function 1 is our bell, function 2 is our whistle, function 3 is our short whistle, and the reason we have that is because this way we can get crisp, nice whistle signals independent of the long whistle, so that you get a really good experience and you can kind of play the whistle as best you can using a DCC system. Now, some of the other ones here we talked about, F11 is our brake application, F12 is our train line charge and train brake mode selection. Some of the ones we didn't talk about in real detail here is F16 is a water stop, F17 is a fuel load, which I did mention, determines what sounds you play when you select the type of fuel. And then other things, you can turn on the injector, the sander valve, and so forth. So you really have a fully operating railroad locomotive here. Be sure to check out our user's guide and also some of our videos on our YouTube channel for more detail in some of these other features. Okay, so now we're going to talk a little bit about the diesels. Now, when it comes to selecting a diesel decoder, there are a few different things to keep in mind. Now, where Steam was a little different, where we had all the sounds loaded into one, our diesel decoders are loaded into 5 different flavors, if you will. EMD, EMD Part 2, GE, Alco, and then the Land of Misfit toys known as the Baldwin and others. And this is where you're going to find out which model you're looking to install. We do have a reference on our website to determine which prime mover sounds are going to be in each of the decoders, as well as which prime mover sounds are in different models that you're going to find. And that way you can match the correct sound to the decoder that you're installing. Now, our EMD is going to be the collection of the most popular EMD prime movers, such as the EMD 567, 645s, and 710s. The EMD2 is going to be some of the more unique versions of that. For example, the 12-cylinder 567 prime mover that you would see in this SW900, the 20-cylinder 645 that you would see in this SD45, and some other unique versions of those prime movers that you're going to find. Now, of course, GE is going to have the sounds for both the early GEs as well as the late GEs, and the Alco is going to have sounds for the Alco. Now, the Baldwin and others is going to be a collection of ones that didn't justify a separate part number. So, for example, you're going to find 4 Baldwins. You're going to see Galloping Goose, Whitcomb, the Fairbanks Morse, the Genset, and the UP gas turbines are all going to live on that Baldwin and others. So be sure to check out the sound selection reference on our website at SoundTraxx.com. Under the reference tab, click on manuals, and then click on the Tsunami2, and you're going to see the different sound selection references. Now, part of the reason this had to be done is because a diesel prime mover sound takes up so much more space than an exhaust chuff, because with an exhaust chuff, you have basically 4 chuffs. But in a diesel locomotive, you have the startup sequence, the idle loop, the notch idle to notch 1, notch 1 to 2, 2 to 3, 3 to 4, and so on, and all those individual. So it takes up much more memory space, and especially since at SoundTraxx we don't clip or edit the sound files any more than just cutting them on end. That way you get the full sound spectrum, so that way if you have speakers that are capable of reproducing those low frequencies, you can hear those tones, and we'll get to that here in just a second. So now once you've installed the decoder and matching, you've got the similar selections like you saw in the Steam decoders. So you have CV120 selects the air horn, CV122 selects the bell. Now, one thing I want to point out here is in CV122, when you're selecting the bell, and this is actually true of the Steam decoder as well, but it's not really common practice. But when you press the horn, in some cases, for example, the modern locomotives, you can hear the bell automatically trigger. Now, to do that, you're basically going to go through the list. You're going to select your bell in CV122, and whichever bell you choose, you're going to add a value of 128 to that bell selection. And that's going to tell the decoder that not only are you selecting the type of bell, but you want to have that trigger when you blow the horn. Now, in CV123 is where you're going to select the exact prime mover. So you have 9 different choices in there, and you're going to find the one that matches. So for example, this GP15, you're going to have an EMD 645 non-turbo, and you're going to select CV123 to match. And that sound will play anytime track power is applied. Now, one of the other things about the prime mover playing is we do have a feature built into our decoders called prime mover pitch shift. And this allows you to take the sound of the prime mover and slightly shift the pitch up or slightly shift the pitch down. And the idea behind this is so that way you can still have the same sound, but they'll sound just a little bit different of all the different locomotives that you have. So this is in CV223, so be sure to try it out, play with it, and see how you like it. Now also again, CV124 selects the air compressor, CV126 selects the type of coupler. Now in CV125, I want to point out there is a thing called Poppet valve select. And what this does is on the early locomotives, when air was compressed, as moisture condensates, that moisture has to be dispelled. And so early locomotives had a Poppet valve that would basically spit the air out. So it was also known as a spitter. So that's where you get the sound. Now on more modern locomotives, such as this Gevo over here, you're going to hear the sound of an air dryer. Now, when you get the decoder, it's going to be defaulted with the air dryer sound, but you can select that Poppet valve for the early one. So again, it's another option to allow you to customize the decoder to match the model that you've installed it in. Now in the Tsunami2, we have our Hyperlights. Now Hyperlight Effects is a harken back to our first product as a company over 30 years ago called the Hyperlight. This was the first processor-driven lighting module in model railroading. And this allowed you to select different lights like rotary beacons, gyro lights, Mars lights, all these different things. And especially on modern locomotives, you're going to see the alternating flashing ditch lights. Now with the Tsunami2, we've added some new lighting features, including constant dim, where you can adjust the brilliance using a CV. So things like number boards or truck lights, things like that, don't appear as bright as headlights on your locomotive. Now we also have a master brilliance in CV64. So you can adjust the overall tone of all the lights together so that way you don't seemingly blind down the track, because early headlights didn't quite look as bright as modern day headlights. So this gives you the ability to make adjustments for yourself. Now with the Tsunami2, this feature, the dynamic digital exhaust, has been in our product for many, many years, but only applicable to the steam. So we're very excited to be able to offer this feature in our diesel decoders as well. So dynamic digital exhaust, as we mentioned with steam, allows the decoder to sense the load on that motor and adjust the tone and intensity of the chuff. But in the case of a diesel, you're actually adjusting the prime mover notching and the intensity based again on what the locomotive is doing. So with a short calibration process, you can dial in that motor to match the locomotive so that way everything works and sounds together. So one way we recommend this is to set the notch rate in CV114 to a value of 15. And what this does is this separates the notching so that way your dynamic processor doesn't cause the prime mover to notch up or down too quickly. Now there's a few other things CV114 does, so I encourage you to check their user's guide. But there's also what's called the interlock bit. You can adjust the auto start, whether the locomotive fires up as soon as track power is applied, or if you have to manually start and stop your prime mover. And then also how the dynamic brakes affect the operation of the prime mover. So in some cases, the prime mover will drop to idle. In some cases, it'll go to 8. We'll cover that here in just a second. Now, the other thing about our dynamic exhaust is that you do have a manual override, so that while you're running your locomotive, you can let the dynamic processor work your notching. But if you really want to dial it in, you can use the F5 to notch up your RPM and notch 6 to notch down your RPM. So really you have full auto manual control. So let's take a quick peek and see how the dynamic exhaust works. So now once we've adjusted the timing and everything with the DDE, let's see how this plays out. We've got two locomotives here consisted together. We're going to move them forward at about speed step 3. And you can kind of hear them throttling up a little bit and then back down. But once we've got this tuned in, we're going to put a little resistance on here. And you kind of hear how they work together, sharing the load and also keeping to make sure that they're more in time together with the notching. This is a great way to add more realistic operations to your railroad. Okay, so that's a really cool effect to really help give you some life into your railroad. So now you don't get that monotonous prime mover crawl, whether you're going uphill, downhill, around the corner. That way you get this dynamically changing exhaust. It really adds that much more fun into your railroad operations. Now, like we talked about on our steam, our diesel locomotives have at least two braking systems on the locomotive. Again, the independent and the automatic. And they're going to work very similar to what we did in the steam. So again, function 11 applies the brakes. Function 12 will determine which braking system is active. And when you turn on F12, it will actually trigger the train line to charge, so you'll hear that compressor kick in. And also it will notch up the prime mover as it's working harder to turn that compressor faster, so that way it can charge the train line more quickly. Now, one of the things we're going to do is set some momentum. Again, you're going to notice the values are going to be very similar to what we did before. So CV3, we're going to start with a value of 75, and CV4 for deceleration, we're going to start with a value of 150. Now, in our train brake, we're going to set CV117 to a value of 178, which again represents a minus 50. And then we're going to set CV118 automatic train brake to a value of 75, which will represent a plus 75 rate to the braking in CV4. Now, in some of the diesel locomotives, you're actually going to get a third braking rate. And the idea behind this third braking rate is to try to help keep the train under control. This is called dynamic braking. So rather than wearing out the brake shoes as a train is descending a hill or a grade, you wear those brake shoes out really quickly with all that tonnage. Locomotive engineers introduced dynamic braking, and what this does is this takes the electric traction motors that are located down on the trucks and turns them into electric generators. That electrical energy is generated and causes a slowing of the wheels through the traction motors. That electromechanical resistance is what slows the train and tries to help keep it under control. So rather than using brake shoes, you're using that regenerative braking. Now, that energy has to be dissipated somewhere. And so up here in the dynamic brake grid, you have a bank of resistors. Now, this is where that energy is dissolved, and it goes through the resistors and turns into heat. And that heat has to be dissipated. And so you have the dynamic brake grids up here. You have a few extra fans. So the sound you actually hear when you press the F4 is the sound of the dynamic brake fan as it's blowing air across the resistor grid. Now, in CV116, we can actually set a dynamic braking rate that will slow the train independent of our independent and automatic train brakes. So that way you can have 3 train brake systems. Usually when I set this to the absolute max, longest amount of time, which is CV116 to a value of 125. And it will drop the train down to about 7 to 10 miles an hour. Now, also using dynamic brakes, as I mentioned with CV114, you can adjust how the dynamic brakes affect the operation of the prime mover. So the prime mover will either drop to idle, you can go to notch 4 like the Southern Pacific did, or the Missouri Pacific in their SD40-2C units, the coal units that had the actual dynamic brake grids on them. Those were used primarily for interchange service. Or you can go to notch 8 like some of the early Alcos did, because the fan was mechanically driven off of the crankshaft. So to turn the fan the fastest, of course, you had to go to notch 8. So you can adjust this again in CV114 to determine which model you're going to apply. So let's take a quick look and see how that operates and how the braking looks in a real-world situation. Now with diesel operation, we look at our function mapping chart, and you can see a lot of the same type of things that you're going to see in our steam. So there's a lot of compatibility designed for when you're running those locomotives. So in the differences, F4 is dynamic braking, whereas on our steam locomotive, it was the cylinder cocks. But you're going to see a lot of the same type of thing. F5, F6 is our notch up and notch down. F11 is our brake application. F12 is our train brake charge. Things like that. F17 is our fuel loading, as we talked about again. Now, some of the ones we're not really going to get into too much here is HEP mode, head-end power. So if you've got a Amtrak locomotive that's running head-end power, this will match the prime mover accordingly. So when you're selecting an F40PH or a P42, you'll have the proper prime mover sound for HEP power. Now, function 20 is what enables a steam generator, and early passenger trains needed steam heat for the passenger cars. Now, modern diesels, more of them are going to a separate auxiliary HEP pup motor, and so there is a CV that you can select which one of those plays, and then you can determine that activation in function 20. Now again, these are the default function mapping. You can change these however you like. I personally change these up quite a bit, so be sure to find out what you like or what makes sense to you. You can change the function mapping around however you like. Now, some of the other things I'll get into really quickly before we get into consisting is what's called the 7-band equalizer. Now, as I mentioned earlier, SoundTraxx gives you the full sound spectrum. So when you hook this decoder up to a full range speaker, you're going to hear all those low ends. The biggest limitation is going to be the speakers that we're forced to use in our small models. So the 7-band equalizer allows you to adjust and compensate for the speaker's strengths and minimize its weaknesses. And so these low frequencies that a speaker physically can't do, you can filter that out with the 7-band equalizer. But you can also boost the low frequencies that it can reproduce. So in the case of our Minicube speaker, which is capable of down to 100 hertz, you can really kind of boost that mid-range and low range to get the most out of that sound. Now, also we have a high pass filter, and that's stored in CV224. So that way, once you know the speaker's frequency range of what it can reproduce, you can actually save energy on the amplifier and also minimize distortion in the speaker by filtering that out. It's the first in our industry and the only one to offer it to date. Now, some of the other audio tools we have is the ability to add echo or reverb into some of the sounds. Now, in CV161 determines the percentage of those echo and sounds into the air horn. So I encourage you to play with that, try it out. Again, check our user's guide for details on information on how to use that. Now, we also have a full alternate volume mixer, and this is a whole second set of volumes that you can enable with a function. So for example, if you're running at home versus running at a club scenario, you can have two different sets of volumes to be able to determine what the volume level load is going to be. Now, one of the other things our Tsunami2 introduces is what's called Hyperdrive 2. This is introducing a really refined motor control that allows you to really creep along the rails at a very slow speed if you like. It's fully adjustable. We also do have 3-point speed curve as well as a full 28-point speed curve, so you can create any speed table that you like. A couple of ones I'll point out. CV215 is what's called back Emf Reference. So if you're operating on a home layout and you tend to operate around the 13 volt range, I would encourage you to have that match, and you're going to get better slow speed performance. And then the other one is called CV211. It's slow speed compensation. If you have a gearing mechanism that's kind of catching a little bit more frequently, you can adjust for slow speed compensation 0 to 100% equals 0 to 255 value in the CV. So if you have a locomotive that you notice surging a little bit at slow speeds, play around with that, and that'll help eliminate a lot of your problems. Okay, now we're going to talk briefly about consisting and kind of some of the things that's going on behind the scenes so that way you can have a better understanding. Now, first off, I will mention that we do have a full comprehensive video on this in our webinar series, webinar number 14. So search YouTube for SoundTraxx webinar 14, and we'll have a lot more detail onto this. But let's get into a brief discussion on what consisting is, and then we'll talk briefly about the different types. So first off, consisting is running multiple locomotives together as if they were one train. This is mostly done with diesels because diesels are designed for multiple units. So they could do lower horsepower units and just have more of them. And that way you can have a train that dedicates to the horsepower to the tonnage that you're pulling, rather than a steam locomotive where if you had two units, you have actually two separate crews running those trains. So what we're going to do is, one of the things I always recommend is having consistent function mapping. And having consistent function mapping is going to make consisting diesels easy. So what that means is having every locomotive in your roster in diesel to be able to have the same buttons do the same thing regardless of which locomotive you're controlling. Number one, it makes it easier for your operators, but number two, when you get into consisting, it's going to make it a lot more easy and fun. And again, consistent momentum rates and braking rates. So again, that way every locomotive will run with every other one on your train, and your operators get a predictable idea of how long it's going to take for their trains to stop. So let's talk briefly about how the DCC signal works. So when the DCC command comes from your throttle, the command is basically, hey everybody listen up, locomotive, we're going to use locomotive 2272, move forward, speed step 10, turn on F0, turn on F1, turn on F4. So this is basically what the DCC signal is doing. There's no feedback from the decoder that says, hey, I got it, or anything like that. It's just a one-way communication, broadcast only. So when you're consisting, there's different methods that's going to be the most efficient for your DCC system. So first off, let's look at what a simple consist does. And a simple consist would basically force all three locomotives to run the same direction. You're going to set them all to the same address. So we're going to set them all, say, to 1575, 1575, and 1575. So with my DCC command, hey everybody listen up, locomotive 1575, move forward, speed step 10, turn on F0, turn on F1, turn on F4. All three of these decoders are going to get that command. So what happens is they're all going to move forward, speed step 10. So you're limited in elephant style, unless you go in and start changing parameters on how the decoder behaves. But this is where we'll have a way to override that. So this is where, you start messing with how the operation of the locomotive is. If you decide you want to run this guy by itself, now you're having to go and undo all that. So let's talk about function 0. So now we turn on our headlight. So the command to 1575, each of these locomotives are set, all three headlights are going to come on. What happens when we blow the horn, the F2? You're right, all horns are going to blow. So how do we fix that? We go in and set the volume of the horn and the bell to 0 on these guys. Again, if I want to take this locomotive and run it independently, I'm now having to go undo all of those pre-described configurations so these locomotives run together. So it's not very realistic. It gives you a lot of limitations, and yes, it's simple, and the DCC command does send one command out to your train. But again, if you decide you want to run this train, or let's say, for example, you forget that it was part of a consist and I want to run this locomotive by itself, how come when I'm selecting 2272, it's not running? What's wrong with this? Because you forgot it was part of 1575 2 weeks ago or a month ago or whatever the case is. So a simple consist doesn't really help add up quite a bit. It does make it's down and dirty, it's easy, but it doesn't give you a very realistic effect. So now let's look at a basic consist. Now a basic consist is stored in the DCC system memory. And basically your DCC command is going to be, hey everybody listen up, locomotive 1575, move forward, speed step 10, turn on F0, turn on F1, turn on F4. Hey everybody listen up, locomotive 1587, move forward, speed step 10. Hey everybody listen up, locomotive 2272, move reverse, speed step 10. Now did you hear anything missing out of those trailing two commands? That's right, you didn't hear any functions. Because when your basic consist, or what I've heard is called universal consisting, is stored in your consist or in your DCC memory, what happens is it knows which one is the lead, and so it sends all the function commands to it. Keep in mind, when these were developed, we didn't have sound decoders, so the only thing that was pertinent was the lights. And so that's why this design is done this way. So the lights would be on the lead unit, which would be correct. The trailing units now. So what happens if you want to turn on the F11 brake? Well, when you turn on the F11 brake, the lead unit's the only one who's going to get the command. So these two guys shove it down the track, which again is not very realistic. You want to distribute those sounds amongst the other locomotives. Now the other problem is if you want to go from your home layout to a club layout, now you have to go build that other consist again using their DCC command station. Now as you can imagine, in a club layout if everybody's building these consists this way, this is now 3 commands for my train. What happens if we get into a club large enough to support 5 or even 10 operators running at the same time? Well, that's possibly 15 to 30 different commands that are being sent through the DCC system, in addition to other ones that may be Locomotive 1000 sit still, no functions. That could be an active command on the throttle. So what happens is when you get to a club environment or one of those type of things, you can experience throttle command delays. So if I'm trying to blow the horn on my train, there may be so much DCC traffic that it causes my command to be slowed, and so it's not actually able to blow the horn as quickly as I would like. Which is another part of the reason why we have the F3 as our short horn, so that way you get that instantaneous horn response. Now again, as I mentioned, this doesn't transmit from layout to layout. It is bulky, it's a little bit tougher to do, and if I forget and I try to run this guy by itself, then the DCC system thinks it's part of that consist, so I can't talk to Locomotive 2272 by itself because it thinks it's part of consist 1575. So this leads all kinds of other problems, and as much as I would love to say the DCC systems don't always kill the consists the way we hope, so there's a lot of times you have to kill it 2 or 3 times before the memory actually kills the consist. And so this leads to a lot of problems, and especially in our day of modern mass-produced models, I'm sure there's more than one Mopac modeler out there that has Locomotive 1575. So if I've got 2 of us at our club, he's been running it in his consist, he goes home, I come in the next day to run my train, and I don't know that he's been running this consist. My DCC system now doesn't recognize my locomotive because it thinks it's part of another consist. You can see where these type of problems can come up very quickly. So the way I actually encourage is what's called a true advanced consist system. Now the consist in this case is stored in the memory of the decoder. And you tell the decoder, hey, you're part of this consist and you're going to respond to these functions. So when I grab my throttle and start dialing up my locomotive, I select my locomotive consist address. So for example here, I'm going to use consist 20. And we'll show you how to set this up in a minute. So when I select Loco 20 and I run my train, these 3 locomotives set up just like they are, all know they're part of consist 20. So when the DCC command comes out, hey everybody listen up, Locomotive 20, move forward, speed step 10, turn on F0, turn on F1, turn on F4. So what happens is the decoder in its memory says, I'm part of consist 20, and then looks to the settings that you've set to determine which to respond to. So moving forward, speed step 10, number 1575 says, yes, I'm supposed to move forward, speed step 10. Now it says F0 being the headlight, yes, I'm supposed to turn that on. F1 for the bell, yes, I'm supposed to turn that on. F4, let's assume it has dynamic brakes. Yes, I'm supposed to turn that on, and then does so accordingly. Now the second unit here, 1587, hears that command and says, yes, I'm part of consist 20. So move forward, speed step 10, yes. Am I supposed to respond to F0? No, no headlight. Am I supposed to respond to F1? Nope, no bell. Am I supposed to respond to F4? Again, let's assume it has dynamic brakes. Yes, I'm supposed to respond to dynamic brakes. Now the last one here, Locomotive 2272, says, hey, I'm part of consist 20, but I'm supposed to move reverse, speed step 10. So it moves in reverse, speed step 10. Its F0 command comes through. Am I supposed to respond? Nope, ignores that command. Am I supposed to respond to the F1 command for the bell? Nope, it ignores it. Am I supposed to respond to dynamic brakes? Again, let's assume it has dynamic brakes. Yes, it does, and it responds accordingly. So you can see how an advanced consist will allow you to control this train more realistically than anything else in the past. So when I issue that F11 command, all 3 of these locomotives are going to respond to the F11 brakes because I've told it to. So one of the best advantages is once you set this up, let's say for example this is the locomotive set I've got running on my layout here, and I want to go to the club. Well, the good news is all I have to do is pack these up, put them in a box, take them to the club, put them on the track in the exact order or facing direction. That's the key point there. I select Loco 20 on the club throttle, and my train runs exactly the same way it did right here because, again, it's responding to the DCC command to address 20. The best part about this is when you get into a club environment with those same 5 to 10 guys operating trains, that's only 5 or 10 DCC commands that are operating. Whether they're running a single locomotive by itself or a consist of locomotives, they still only have that one address. Then, when they're done with their throttle, they put it away, somebody else can come in and with the exact same road numbers in their train, they can put it on the track and everything will run just fine because this address 1587 was never used in this consist. So if I come over and want to run 1587 by itself, the DCC system has no idea 1587 was ever used because it was built as part of consist 20. Now, how do we do this? Now, CV19 is where the consist address is stored. It's a short 2-digit address, number between 1 and 127. And what that does is it's basically an alias for your consist. You can use the first 2 numbers of your lead locomotive, like 15. You can use a club member ID number, or in the case of myself, I tend to use my sports jersey number at number 20. And it can be any one of those numbers, again, 1 to 127. You set that into CV19. When the locomotive is facing rearward, you tell that decoder you're part of address 20, but you're facing rearward by adding 128. So CV19 on these 2 guys would be set to 20. CV19 on this would be set to 148. Now the next step is CV21, 22, 245, and 246. And this is where you tell the decoder which functions to respond to. Now when it comes to consistent function mapping, this is where it really pays off, guys, because when I know this locomotive is going to be the lead, or if this locomotive is going to be the lead, it doesn't matter because the value for the lead locomotive is going to be the same no matter which locomotive it is. The trailing locomotives are going to be the same regardless of which locomotive they are, again, because of consistent function mapping. The other advantage to this is that when I'm running my train, I don't have to hit F11 for this guy to hit the brakes and then say F9 for this guy to hit the brakes. That way you get that consistent operation. Now, again, this is where you determine where in the function or where in the consist your locomotive is and how to set it up. So we're going to show you here this screen, and this is going to be how I set the aftermarket decoders to be function mapped and consisted together using CV21 and 22, and then 245 and 246 control the higher functions. There's not a lot of those that I use in the consist, maybe the switching mode F14 and maybe the sander valve in function 21. Now, the higher consisting functions 13 through function 28 are stored in CV 245 and 246. There's not a lot in there that I use for a consist, maybe the F14 for switching mode, and then F21 for the sander valve. And then, of course, with some of my other stuff, I have extra lights, things like class lights, number boards, things like that. Function 24 through 28 give you some flexibility, and you can add those in. So this kind of gives you a very, very brief overview. Be sure to check out our user's guide and the webinar I mentioned, webinar number 14 on YouTube, or you can visit our website at SoundTraxx.com and see the video. So guys, this is everything I have prepared for you today. I hope this has been helpful for you. Be sure to try things out, and if you have any questions, reach out to us at support@SoundTraxx.com, and we'll be happy to help answer anything we can for you. Ultimately, our goal is to help you enjoy your hobby much better than anything else you've ever done in the past. And this gives us an extra step towards recreating the realism that we've been working so hard to do with our model trains.